All right, we're on lesson 2-6, I guess point 1, the scaffolded lesson for solving equations graphically. Today's date is Monday, November 30th, 2020. It's my birthday. I'm 28 today. Well, thank you. Jane, I don't think you need your laptop open. Please shut it. Really quickly, then shut it. Our objective, really quickly today, is to do what? It's nice and short. It's 6 words. Caroline. There they are. All right, so here are the 2 functions that you need to have just for their parent functions. When I say parent functions, I mean the most basic version of an absolute, the most basic version of a quadratic. So absolute value of x. Absolute value just means the distance from 0. That should always be a positive amount because distance is always positive. So the distance from 0, if I plug in something like -1, the distance that -1 is from 0 is 1. Most people think of this as just make sure it's always positive. Sure, that's another interpretation. So if I plug in -2, I get what out, Emily? 2. If I plug in 0, Jaden, I get what out? What is the absolute value of 0? 0, good. What about when I plug in 1, Chewy? I get out 1, exactly. It doesn't switch to a negative. If I plug in 2, why is it not working? If I plug in 2, Leo, I get out a 2. Graph these points, and you should make the rough outline of this absolute value of x. So if I graph 0, 0, 0, 0 is the origin. If I graph 1, 1, 2, 2, and you can probably guess 3, 3, 4, 4. Those are all going to be the points that are going to be on this graph. I can graph -1, +1, -2, +2, etc., etc. And you will see that the graph looks like a V. I would like to point out a few features of this V before we go too much further. And it does go on and on forever in those 2 directions. So a few things that you need to know about this absolute value parent function. The first thing is that this point down here, the point where it turns around, that sharp corner, that's called the vertex. This point right here is called the vertex. I'll also show you that the default slope on the right-hand side, the slope is +1. The default slope on the left-hand side is -1. That's all you really need to know. The quickest way of generating this slope is, as long as you have the vertex correctly, go right 1, up 1. Done. Do you guys all remember right 1, up 1? Right 1, up 1. It's the slope of 1. Right 1, up 1, and then you know that the other way is going to be the same. It's going to be a V. That's your absolute value function. Okay, what about the quadratic function? X squared. That's the easiest function I can make you. That's a parent function. Again, if you don't know what a quadratic function is, make a table. If I plug in 0, 0 squared is 0. If I plug in 1, 1 squared is 1. If I plug in -1, Oscar, I get 1. If I plug in 2, Ellery, I get 4. Why am I lagging so bad? 4. If I plug in -2, Beverly, I get 4. You can graph all these points. I can plug in -3, Caroline, and I'll get 9. And Leo, if I plug in +3, I'll get 9. All of these points we can graph. So 0, 0. It goes 1, 1. And just right here, I want to pause because this is the similarity and why I'm talking about these 2 functions today versus the exponential function. They're really similar. I graph 0, 0, 1, 1. I graph 0, 0, 1, 1. The first 2 points that you graph are the same. right one, up one, but then it kind of breaks the pattern. Then I go 2, 4, and 3, 9. And there's this axis of symmetry again, where I can just kind of mirror it on the other side. And this should have a nice gentle curving slope down here. It should not be a sharp corner. No, exponential has the variable in the exponent. So I'll write over here, exponential. I can't spell exponential. It's something like 2 to the power of x or 3 to the power of x or something like that. The 2 and x would be reversed. And eventually you guys are going to be doing this tomorrow. But for now, baby steps. Just graph these basics. And again, I'm going to be pointing out the same thing. This bottom turnaround point, I'm going to call that the vertex. And to get that second point, again, this point, I went right one, up one. To get this second point over here, for the absolute value function, I went right one, up one. They're almost the same, slightly different shapes. All right, let's move on to something a little bit harder. So the general formulas assume that we have a lot of things happening. Again, you can see absolute value and quadratic. They look really close to each other. When I get to exponential, it's not going to look like this exactly, but you can kind of model it. Notice I'm using the same letters because the letters do the exact same thing to both of these equations. You learn it for one, you memorize it for the second. So I'm going to circle, and I want you to circle with me. What are the things that I'm going to plug in? A, this negative h. I guess I can just circle the h. The h and k, those are all just numbers. They're constants. In that place, you'll have like a 7 or a 5 or a 3 halves or something. You'll have some sort of number. The y and x are obviously the variables that stay behind. So those are all going to be numbers. Number, number, number. Same thing over here. A, h, and k are just numbers that are going to be filled in those spots. I didn't want to confuse anyone by adding in too many variables, but that is the general form. I need to be able to talk about what happens when I talk about certain things. So the order over here matters. I'll write down that the order matters, maybe with a few exclamation points. You have to first analyze h, then you have to analyze a, then you have to analyze k. If you do it in that order, you'll get it correct. If you do it out of order, if you're tricky about it, you know what you're doing, you'll be fine. But if you do it in this order, there are no tricks that you need to know. It's nice and easy. So first, you need to look inside the parentheses, inside the absolute value, the h. This is your horizontal shift. Horizontal shift. AKA how much you move left and right. When you look at the value of h, this will tell you what the vertex is. More specifically, it will tell you what the x-coordinate of the vertex is. So it's used to find the vertex, which is that turnaround point, and specifically, it's the x-coordinate. But the trickiest part about using h is you have to do the opposite. The reason why I randomly did a minus h inside the absolute value and a minus h instead of a plus h inside of the parentheses is because you have to do the opposite. So if you see something that says -2, that does not mean go left 2. It means go right 2. You have to do the opposite of what you would normally think. So right here, do the opposite. If you have a minus sign, that does not mean left, that means right. If you have a plus sign, that doesn't mean go right, it means left. That's the only thing that's backwards. Everything else is forwards. There's only one backwards, and it's inside the parentheses. If we have time, maybe at the end, I can explain this away. It's like a 30-second explanation. It's not too hard. If you solve for x, you need to undo it, essentially. Okay, after you've dealt with h, every single one of these letters is going to move your function around and stretch it and do different things to it. H, what did it do? It moved it either left or right. Next, we're going to talk about A. A is your vertical stretch. I can stretch it or I can compress it. Typically, we think about this in the vertical direction. You could say it's the horizontal direction as well, and you'd be correct. But it's easier to think of it as the vertical direction. The vertical stretch or compression. So we already know where our vertex is. The vertex never moves off of the x-axis. It's always permanently attached. So I have some sort of x-axis. I can drag the vertex left or right using h. Now to find the second point, I'm using the value of a. Remember, it used to be right one, up one. Well, it's going to be right one, and then whatever the height of a is. If a is 2, you go right one, up 2. That'll be your second point. And when you're doing this on Khan Academy, you only need 2 points and you're done. That's why I'm only showing you 2 points as well. It's the easiest way to do this. So you go one right and the height is whatever a is, which means if I have a negative value, that means I'll go right one, down 2, or down 3, or down whatever that is, which means I could have a v that's upside down, or I could have a parabola that's upside down if it's a negative value of a. Only way to make it upside down is if I have a negative value of a. If I have a positive a, it has to be going up. All right, and then finally k, which is kind of the most tedious but easiest guy. K is your vertical shift. We already did a horizontal shift. Now we're doing a vertical shift. So that just means move up or down. So move up and down. The reason why this is tedious is because now you have to move both points. You can't just move one of them. And you're done. This is how we're going to graph each and every one of these. First, how much left or right are we shifting? Then go ahead and compress or stretch it, maybe flip it upside down. And then finally, move it up or down by the value of k. Done. Let's try it. Example number 1. We have this absolute value function. So we know by default, we can even sketch over here, the parent function should look like that. It's a v. That's what it started off with. In each of these graphs, I'm going to progressively make a different shape. So in our first graph, let's just go ahead and graph y equals the absolute value of x minus 3. We're going to ignore the 2 out front. We're going to ignore the plus 1 out on the right. What does just absolute value of x minus 3 look like? Well, it's our parent function, our v, but moved somewhere. Where? Where do we move it? Do we move it up, down, left, right? How much do we move it? Someone tell me. Look at your notes. Graph of absolute value of x minus 3. Someone tell me where the vertex is. The vertex, the y coordinate is 0. It's somewhere on the x-axis. But what is the x coordinate of the vertex? Ellery? 3. Exactly. It's the opposite of whatever is in here. This is a minus 3, so I go right 3. That's the vertex. Everyone graph it. It's the x-intercept at 3. It's this point here at 3. We have the vertex. And then it's your normal V shape. Nothing has happened aside from it moves to the right. So let me actually have a line tool, so I should use that. So there's our V. Shrink, shrink. Now, what happens if I put a 2 out in front of it? Now I'm going to try the equation. I'm going to write it underneath it because I realize that the area up here, I'm going to be using that to graph. So I'm going to do it down here. This is going to be the graph of y is equal to 2 times the absolute value of x minus 3. So it's this previous graph that Ellery gave us. And now all I'm doing is I'm putting a 2 in front of it. How is that going to change everything? The vertex should still be at the same spot. Let's go ahead and graph the vertex again. The vertex didn't move. It's still at 3, 0. But the second point, again, the second point should change. The second point used to be right one, up one. Now it's right one somewhere else. What is the height of the next point, Leo? Right one up two instead of right one up one. Yeah, exactly. So up two means I'm up here and there's my graph. And again, there's symmetry to it, which means I'll have a point on the other side as well. Right one up two, and there's our V, and there's our V. So we can say that this had vertical stretch. It's as if I had the previous graph and I grabbed the top and bottom of it and I stretched and pulled it apart to make this angle slightly smaller. It's a vertical stretch. And we're almost done. Again, I'm only looking at these 2 points when I'm graphing this on Khan Academy. These 2 points here and here at 3, 0 and 4, 2. What's going to happen to these 2 points now that I'm doing +1? So this final graph is the one that you're going to graph on Khan Academy. I'm just showing you the steps that we're doing to see this. This is going to be y is equal to 2 times absolute value of x minus 3 plus 1, the entire equation. What's going to happen? What does that final number do? +1. We're on step number 3. Beverly? Up 1 for both points. This point used to be at 3, 0. Now it's going to go up to 3, 1. This point that Leo gave us at 4, 2 used to be here at 4, 2. Now it's going to go up to 4, 3. And we have our final graph. And I really want everyone to pay attention just to 2 points, because that's exactly what you're going to be doing on Khan Academy. All right, I talked for the front half worth of page of notes. How you following me? Just 5. I'm seeing 5, 5, 5, 3, 4, 4. Okay, our average is about a 4.4. Nice. Let's try another one. Another absolute value. So if you think that you're tricky and you know how to do these really well, you can skip to the final answer. But for the sake of making sure everyone knows what they're doing, I'm going to go through this step by step. Again, I know that this is an absolute value function, which means my parent function over here, my y equals absolute value of x parent function. Oops, that was a bad absolute value symbol. Is just a v. I know it starts as a v. That's its parent function. So let me try graphing y is equal to absolute value of x plus 1. Where's its vertex? Someone help me. What is the x coordinate of the vertex? I know the y coordinate is 0. It's somewhere on the x-axis. Is attached to this line somewhere, but where? Again, think opposite. Jaden, give it a shot. Close. Think of opposite of positive 1. -1. Jaden gave us the x coordinate of the vertex. There it is. And then I go ahead and just make the same graph with the slope of 1, right? So boom. There's that one, okay? Then we go up a stage. We say, okay, now let's go ahead and deal with that number out front. Now let's do y is equal to -3 absolute value of x plus 1. Oh, actually, I'm going to have to write this up above because the -3 I can see ahead. -3 is going to flip it upside down. Let's write this up here. So the vertex is still at -1 where Jaden gave us, -1. But the second point, instead of going right 1, up 1, like we did over here, the second point is going to be right 1, then where? Beverly? Down 3. So from this point, the vertex, I'm going to go right 1 to the origin, then down 3. There's my second point. And again, go ahead and make your absolute value graph. That could have been better. There. And then finally, we need to add 2 to it. So I'm going to write up here, y is equal to -3 times the absolute value of x plus 1 and absolute value plus 2, the new stuff, plus 2. What's going to change now? Sorry, Beverly, I'm going to give it to someone else. Leo. Add 2, what does that mean? So are you talking about moving up and down or left and right? Up and down, okay. How much up or down am I going to move? 2 up or down? It's actually positive. So this, the only thing that's opposite is on the inside. So this one, just think of it, +2 means up 2. Yeah, so up 2. So this point used to be here. Let's go up 2, and it's going to look right there. This point down here at -3 is going to go up 2. It's going to be at -1. Use the axis of symmetry to think of this as a third point over here. And graph your equation. There it is. Let's try another one. Example number 3. Ooh, this is not absolute value anymore. It's quadratic. It has something squared in it. So when I think of my parent function, my y equals x squared parent function, it's some sort of parabola, some sort of smiley face. So again, I'm going to try graphing. What does y equals in parentheses x minus 1 quantity squared? What does that look like? Well, find the vertex. That's your first step. What is the x coordinate of the vertex? It's going to be somewhere on that x-axis. Oscar, where do you think it's going to be? On 1, yeah, on +1. It was the opposite of -1, so we went to +1. There's the vertex. And again, what do? Write 1 up 1. That's the default assumption. Write 1 up 1. And then you can kind of sketch it from there. I know that you could probably say, okay, you go up 1, then 3, then 5, then 7. You go up odd number amounts. So I went up 1. I go up another 3 from there. 1, 2, 3. Et cetera, et cetera. I go up 1, I go up 1, 2, 3. You can have all these extra points on here if you want. But the main thing is you have these 2 points, and then you can kind of sketch it from there. Okay, let's try doing the next step. It's a little bit tricky now. I'm going to write it up above because I noticed that there's a negative out front, which should flip it upside down. So what is y equals negative in parentheses x minus 1 quantity squared look like? Again, vertex has not moved. The vertex is still at 1, 0, where Oscar told us it was. But instead of moving right 1 up 1, I'm going to move right 1 then somewhere else. And there's no number, so you'll have to do a little bit of detective work here. Chewy, you want to give it a shot? What's this number out front? I go right 1, then... Chewy, are you awake over there? If that was a number, what number would that be? If you don't see a number, what times something is itself?
1.
1, yeah. So this is really secretly a -1. So that means I'm going to go right 1, then where, Chewy? Up or down?
Up.
Not quite. It's a negative.
Down.
So down how much?
1.
Down 1. My 2 points are right here and here. Essentially, all I did was I flipped this over the x-axis. It was a reflection. And then I go ahead and I sketch my graph. It should be slightly more curvy, but whatever. And then I have my final equation, which is going to be just rewriting what I was given. Y is equal to negative, in parentheses, x minus 1 quantity squared plus 3. What does that final step do? Emily, you want to help us out? If I add 3, what does that do? It moves the graph, but does it move up, down, left, right? Up, how much? Up 3, yeah. So these were the original points. I go up 3, 1, 2, 3. I have this point down here at 2, -1. I go 1, 2, 3. And those are my 2 new points. Again, go ahead and sketch your graph. If it helps you, you can go down another 1, then down another 3, 1, 2, 3. Then down 5, 1, 2, 3, 4, 5. Have these extra points on the graph. All right, I want to be able to walk around the room and see everyone work on example 4 on their own. Again, you should split this into 4 different graphs. Your parent function should be your first graph, and then each individual step, I want to see them. If you're already at that level where you can skip ahead to the very end, that's awesome, and you will breeze through the homework. But I think for most of us, myself included, I would like to do step by step to make sure I'm doing them correct. All right, so good luck on example 4. After you finish example 4, you can do your summary, and then you have 2 homework assignments on Khan Academy. And I forgot to do the recording in class, so let me finish it right now that the bell is rung. For this one, again, our parent function is going to be y is equal to x squared. It's going to be some sort of parabola shape like this. So if I do x plus 3, y is equal to this quantity of x plus 3 squared. It's going to go left 3. And then to get my second point from the vertex, I go right 1, up 1. And then just roughly sketch. It doesn't need to be exact. A parabola that goes through those points. The next equation that you're going to have is going to be just adding the 2 in front of it. So you get y is equal to 2 times the quantity of that x plus 3 squared. Again, the vertex hasn't moved. It's still here at -3. But the change is instead of going right 1, up 1, it's going to go right 1, up 2. And then go ahead and sketch what that graph looks like. Looks like that. It's a nice curve down there. And then finally, our equation is going to move everything down 1, -1. So this y is equal to 2 times the quantity of this x plus 3 quantity squared minus 1. This point used to be at -3, 0 right here. I'm going to go down to -3, -1. This point used to be up here at -2, 2. Again, just regraphing that point. And it's going to be moved down here. So down here. And again, just graph or sketch a line, sketch the curve that goes through those points. Oh, that was terrible. Let me try again. Slightly better. It needs to be a curve, not a sharp point. Good enough for me. And that concludes Precalculus Notes 2-6.1.